Italy, she saw these little puppies. Okay, and they were so cute. I gave them their own slide, but now they are part of our slides. Okay, so little puppies from Italy. If we get out our implicit differentiation worksheet, this is why you don't want to work it on the paper itself. Later on, I think I just did it on my notebook paper so that I could actually read what I was trying to squeeze into the side. So it's a good idea to do that. I'll be taking questions on the implicit differentiation worksheet. As I go, we'll also be reviewing notations, product rule, quotient rule, chain rule, and then your homework is going to be on product and quotient rules. I don't even know really if it has any chain mixed in, but it's some good AP questions just to get you used to it before my test.
Can we go over 7B?
This is 7. I'll just do all of 7. Okay, some of you have already
Oh, yeah.
a bunch of you have met with me this morning, but I think y'all were okay with seeing this again. Okay, remember that we're going to be very literal. That'll save you sometimes. What I mean by literal, if you see the equation of a tangent line, you need the slope. How are you going to find the slope of a tangent line? You need the first derivative. Okay? The first derivative gives you the slopes of the tangent lines. Once again, before I even do that problem, if I have y is equal to x cubed and I get y prime equals 3x squared, and by the way, my double prime does tell me something interesting, but besides that, I want to reiterate something I have on my schedule to tell you on Monday. This gives me 6x. This one is odd, this one is even, this one is odd. You see how it rotates, revolves back and forth. That can be important in some things that you see. If I look at an x cubed graph, and if I really drew it, it really levels off right there. And so the slope at 0 is 0, and the slope at 1 is 3. The slope at -1 is 3. If I go out, y'all see how this is matching? I've done that for you a few times. The first derivative has a variable in it quite often because your slopes are changing, but it's really cool how it happens. Sometimes you can slide out of it because we just know the trick, and we should go, oh wow, how'd that happen? But remember, I got those from f of x plus h minus f of x over h. dy over dx, the difference quotient, okay? So a derivative is f of x plus h minus f of x over x plus h minus x, and we take the limit as h approaches 0, or f of x minus f of a over x minus a, and take the limit as x approaches a. Right here in purple, that's what I call a Lazari term. That's what I call crummy slope. That's also what your physics and your math teachers will call the difference quotient. You're seeing where it's come from where it was, okay? Like I went 400 miles in 3 hours. I've subtracted how far I traveled over how much time it took me. It could be in October I made, a certain grade on the test, but by March I was making another grade on the test. So I've improved my performance on the test over however many months that is. It's a difference quotient, okay? As soon as I do this though, now we put on our Superman cape or our magic wand or whatever. And so these were 2 points that were just any 2 points in the world. Notice that I reiterated this right here. I know it's over h, but we lose sight of the fact that that's x minus x, right? This is x plus h minus x. So it slams one point into the other, doesn't it? So it squeezes ever closer. It gets ever closer, and that way I've virtually found a slope at one point, and they called that the derivative. The reason that I'm saying all of this again, even though I've said it before, is there's a maturity that sort of happens where this aha moment may happen 2 weeks after I teach the topic, okay? Aha moments are great. I will tell you, I wish anyone was here to hear this, because everybody needs to hear this, and Anna and Alana. I felt like the whole time I was in Cal 1, I felt really solid in Algebra 2 and pre-calculus. The whole time I was in Cal 1, that I'm hanging on by my fingernails. And like one day, somebody's gonna pull me up onto the surface with them. And I just felt like, I hope everything turns out okay. So anyway, but it's not a bad thing. If you think about things that you're going to be doing in life, I feel like that is honestly is I didn't feel like that in my other school, but at Marymount, sometimes I feel like I'm hanging on by my fingernails just via the emails I have to read, much less anything else. I'm sure that your parents sometimes feel like that they don't really fully understand everything that's happening in their job, and they have to dig and talk and collaborate and figure it out. And so if you feel that way, you are not alone. If you feel like you're just hanging on the wall by your fingernails, that's how I feel. And I'm a math major, but that was not alone. Guess what the people felt like they were in my class. Now, I strive for you not to feel that way. I strive to pull you up, you know, to where at least your body's on the edge, okay? And then, but you'll have, I tell you what I had, and you'll have this too. Along the way, I would have these aha moments that just like reeled me along, if that makes any sense. And of course you get comfortable with the older material by the time something else hits you in the face, I know that. But there's a comfort that will come, okay? But if you're feeling that way, you are not alone. I say this at the beginning of every year, and I forgot to tell y'all. If you feel like, oh my gosh, this is so boring, then enjoy, because you're probably one or two people in here will feel that way. Occasionally I've taught someone AP Cal BC that didn't ever have a question, and they just got it all, and they're just nice to sit in there and listen to, okay? But that's highly unusual. It's also unsettling when you've been this math, like, prodigy, you know? Like, I felt very, I was a math prodigy, but I felt very comfortable where I was until I got to college, okay? But I strive to make it clear to you and understand, to where you understand what's going on. So anyway, back to this. This is also crummy slope. This is just any old point somewhere, okay? As soon as I do that, it's the derivative. But the reason I'm going over this is questions I was getting this morning where things are in a fog. I really am in a hurry, so I write that notation a lot, but it means this. It means I took y minus y over x minus x. That's what that means. I told y'all once in class, and you know, a college teacher, which is technically what I am, we tell you once and expect you to know it, but sometimes that doesn't happen. With those little 2's there, that means second derivative. It's the same as y double prime. On multiple choice, it doesn't matter which notation you use. On free response, you'll see next week there'll be a problem that I probably put on the test that says show that dy over dx is like 7x squared. At that point, I would actually use their notation. I can't see us counting off if we don't, but it just sort of makes sense, okay? The reason that they did this is probably was it during the time when people were only writing dy over dx, continuing to talk about this is rise over run. Okay, but it's a really tight rise over run, which was happening at that moment, then the next moment, then the next moment. And so if you're using that notation, it doesn't work just to put both of those 2's there. That actually means the first derivative squared. So that's why they have that little mixy-matchy 2 thing, so that you know you're taking the second derivative. Okay, there's all kind of notations. There's another one that looks like this. And we won't always have x's and y's, so we've got to really read this. This might be a dA/dB. It might be, soon it's going to be a dy dt. What do you think that means? Dy dt, dx dt. The change in y with respect to time. Dx dt would be the change in a horizontal change with respect to time. So you've got to really, I'll say this all year long, follow your variable, follow your variable. So that's just a little laying the groundwork. Because I feel like once I teach you all the theory, then I teach you the tricks. Sometimes we lose sight of the theory and what in the world are you doing. Greg's question?
No.
Okay, so let's go to number 7. This is number 7 on implicit differentiation. All right, so number 7. Consider the curve by the equation y plus cosine y equals x plus 1. Okay, and Emma pointed out this morning when we were working this problem that you're only on the interval from 0 to 2 pi, which saves you some work, okay? Now, let's read the question. consider the curve, all right, find dy over dx in terms of y. So I'm gonna actually use their notation instead of y prime. What I taught you last class is that after every time you take a derivative of something with a y in it, you have to stop and say either y prime or dy over dx, okay? But remember I said you always have been. If you had y equals 3x cubed plus 5x plus 2, the derivative of this side was 9x squared plus 5. What did you say on this side? You didn't say y equals, you said what? Y prime. Okay, so you've been doing it after every y. It takes a lot of discipline. You get better at it as you go, but as soon as you feel confident, then I can make mistakes like this. These are mistakes you're prone to make. As you're really on your game for a few y's, and then you hit another y in the problem, and you forget to go to y prime. And then it messes up your whole thing. All right, so let's go on. The derivative of y to the first is just 1, but I took the derivative of y, so I'm going to say y prime or dy over dx. The derivative of cosine of anything is negative sine y. Using the chain rule, though, I have to go back in and take the derivative of y, which is y prime or dy over dx. So don't ever think the derivative of cosine of y is negative sine of y. That's not true. The derivative of cosine x is the derivative of cosine 2x is negative sine 2x back in times 2. Okay, you'll always go back in. So take the derivative of whatever's back here, I don't care what it is, keep it for a minute, and then put your y prime. The derivative of x is 1, and the derivative of 1 is 0. All right, now, so now I've got to find it in terms of dy over dx. So I'm going to factor out dy over dx, and that leaves me 1 minus sine y equals 1. And so my first derivative is 1 over 1 minus sine y. So that's my first answer. I happen to have the luxury of having all my y primes on one side. If they're not, get all of the y primes on one side, shove everything else to the other side, and solve for it. All right, now we're ready for B. Write the equation of a vertical tangent. All right, this thing that I have is probably not even a function, okay? So I've shown you some things before that have vertical tangents. Like this has a horizontal tangent, this has a negative tangent, that has a vertical tangent. You've gone like over an edge until you like come back around. So that's where I said be very literal in what you're doing. This word over here, you're gonna read some problems and go, what am I supposed to do? Just pick a word that you can do, and then pick another word that you can do. All right, so write an equation for a vertical tangent. All right, tangent means slope, vertical. What's the slope of a vertical line? Undefined. So the bottom, this is slope, by the way. So that's slope, and the slope has got to be undefined. Usually that means the bottom is 0, okay? So I'm on the B part. I'm showing my work as if I'm doing this free response. This really was on an AP test one time. Sometimes I can even tell you the year. But to do a vertical tangent, you show the grader, which is me right now. You're setting the bottom equal to 0 because you want it to be undefined, okay? You have to be careful and not make the top 0 also though. A vertical, that would be a hole in the graph and not vertical, okay? So it's got to be, the bottom is 0. That gives me 1 equals sine y. And so I'm thinking of what y equals. It may be a list of them. So the sine of something equals 1 pi over 2. But sine hits 1 over and over and over and over again, like it does it at 5 pi over 2. It hits it again at 9 pi over 2. Every time I hit the top of this thing, I'm going to get 1. However, they told me I didn't have to check all that. It just takes me through one rotation, right? So in this problem, I only use pi over 2. That's the only time it equals 1. A whole lot of students, when we're grading AP exam, asking for a vertical anything, they'll think they're through, okay? Y equals pi over 2 is not a vertical line. Y equals 7 looks like what? Okay? So all you really have right now is your Y component. Do y'all see what I mean? To get that. So it's happening when Y is 2, but I want to know this. So what's happening is this, whatever this function looks like, I don't know what it looks like. I'm sorry, it's not even a function. But what happens is now you know the y coordinate where you have a vertical tangent. So you're going to need to fill this in somewhere to find your x coordinate. Okay. Fill it into the what?
1/1
Fill it into, no, the very original, not the derivative.
What?
Okay. Always fill it back into the original to find your entire point. So the curve was y squared. Oh no, it wasn't. I'm on the next problem. The curve was y plus cosine y. I'm gonna fill it in as I go. It's y plus cosine y equals x plus 1. Put in pi over 2 and pi over 2. So I get pi over 2, the cosine of pi over 2 is 0, equals x plus 1. And so my x coordinate is x is equal to pi over 2 minus 1, which is about 0.57. Pi over 2 is 1.57 something, 12 I think. So anyway, that's some number. So this, I don't know what the graph looks like actually, but this has happened at this point, so that is actually my vertical tangent. It creates a point at pi over 2 minus 1. It creates a point at pi over 2 minus 1, comma pi over 2. Okay? All right, so is that okay, Grace, for me? And now let's go in and find the second derivative. Okay, let's go in and do C. All right, here's my first derivative right here. Are y'all okay if I erase underneath here so I can just write C under? Y'all sure? Okay. If you need to fast forward to this part of the video, you can do now. Okay. So the C part is now I'm going to find the second derivative. I'm going to use their notation. Okay. I have two choices here. I know that Celine knows this well, but I don't know who else does. We've just talked about it a few times, or she figured it out herself. Please do not try to avoid the question mark, okay? What I mean by that is if I had this, okay? If I had this, y is equal to 7x sine x over x squared plus 3. Every year I have some students that want to do this. They want to take a moment to rewrite it. 7x sine x times x squared plus 3 to the negative 1 power. And then they'll use the what rule? What's the overriding rule there? Product rule. What will you encounter during that time is the chain rule. But girls, I'm not going to throw myself into, that's going to be worse than doing the quotient rule. So I don't know if I'm hitting home with anybody right now, but usually I have a student that's like, I'm not going to use the quotient rule, I'll need the quotient rule, and they'll try to get away. That's even worse. So don't do that unless there's a constant on the top. If there's a constant on the top like this, just a constant, not 7x, but just a number. It is a good idea to do it, because if I go low, what's going to happen when you hit D high? You're going to get 0, so you're sort of wasting your time at that point. So if I have a constant on the top, I will treat it like a coefficient many times, and I will do that. I'll get the same answer either way, okay? So let me show you with this one. What if I had done the quotient rule? Low. Look what I did, girls. After y, I'm taking the derivative, I said y prime. Now I'm going low. The derivative of 7 is 0, minus high. D low is 2x, no reason to put a y prime, over low low. This just all goes to 0, and I get negative 14x over x squared plus 3 squared. If I had done this one in red, if I had done that one,
Can't get rid of it.
don't want to leave. I can throw it. Let me see.
Dog abuse. Animal abuse.
Why is it not working? Usually I can throw it and it'll bounce around. But anyway.
Aww.
Okay, so I could rewrite it, as Celine noticed earlier. I could, if it has a constant on the top, as exactly how she worded it to me this morning, I would do what I'm about to do. If it had, only if it has a constant on the top. So now I do not have to do the product rule. Can y'all see I do not have to do the product rule because that's just a coefficient. You could think it wouldn't hurt you. First times derivative of the second, what would happen when you get to second times derivative of the first? It would go away, okay? So now y prime, this is just a coefficient, -7 times x squared plus 3 to the -2. Am I through with this derivative?
No.
Okay, that's something to the -1 power. -1 times blah to the -2. Now I've got to go back in and take the derivative of the inside, which is what? 2x. And don't you get the same answer really fast? Because that negative exponent just dropped to the bottom. Okay? All right, so having said that and established that fact, you'll see me do this because it has a coefficient on the top. I'm going to rewrite that as 1 minus sine y to the -1. Two things happen to people at this point when you're doing a chain rule. Either you do too much too soon, or you don't finish it, or you do it right. I like option number 3. Okay? Option number 1 is you're trying to bring down the -1 while you're taking the derivative of the inside. And I keep saying, the chain rule, you take the derivative of the outside, leave the inside alone, but go back in for it. Okay? And some people forget to ever go back in for it, so there's all that mix of stuff. Okay?
Just multiply by 1.
So I'm going to go -1 times 1 minus sine y. I'm just leaving the inside alone right now and subtracting 1. I just treated that like u to the -1. So I went -1 u to the -2. Now I have to go back in for the derivative of the inside and create my chain. The derivative of 1 is 0. The derivative of negative sine y is negative cosine y. But I just took a derivative with a y in it, so I have to stop and say y prime, or in this case I'm using their notation, dy over dx. Now, I think they said to, hang on just a second. I'm going to answer your question in just a minute. What was I going to say here? Oh, I know what I was going to say. Is sometimes they say find the second derivative at a point, and this happens later on this worksheet that I'm not going to get to today. They say find the second derivative of the first derivative at a point. Don't clean that up. Start throwing numbers into it right now. It'll be a lot easier for you. If that doesn't hit home, it will one day because you'll look up and go, oh, well, I wish I had messed with all those variables just to fill the number in later. Fill the number in at the first, okay? Okay, before I go on, I'm not through.
If it's negative sine y, then y, like, wouldn't it become positive? No,
The derivative of sine y is cosine y, but it happened to be behind a negative. That negative came from right there, like this. What's the derivative of this, Caitlin? What's the derivative of that?
It's negative cosine y.
Wait, what's the derivative of this? Just this. Look over here. What's the derivative of that? Anybody? Cosine x, right?
Oh, yeah, because
Okay.
cosine is negative.
But what if I, no. So stay with me. What's the derivative of that? 4 plus sine x would be what?
Cosine.
Cosine x. But what if I have this, Caitlin?
It's negative cosine.
Why is it negative?
Because it's negative sine. Yeah, I did this.
it looks like that I'm all of a sudden saying the derivative of sine is negative cosine. It can be very
Yeah,
I
confusing.
think she was asking about the 1 minus sine y, which just stays the same because.
Oh, was that not even what you
No,
were
I
asking?
just got confused. Like the derivative of cosine is negative sine x and not. I just mixed it up. I just mixed my own derivatives up.
And it can be very confusing.
Yeah.
And never mind when we start going backwards, then the negative switch. Okay, so for everybody, that came up with my group this morning that was listening to me. Somebody asked, like, why is it negative? Because the derivative of sine is positive cosine. Where's that negative coming from? The negative sign's just right in front of it. So it's just like 1 minus that, so it's 1 minus the derivative of sine, which is only cosine. Okay? A lot of things, places you can get tripped up. The derivative of sine is positive cosine. That just happened to be behind a minus sign, which I don't even think what Caitlin was asking, so I'm over answering the problem. Okay?
Why is there negative 1 in front of it? Remember that?
Oh, I'm taking the derivative of this. The first thing I do is bring down my negative 1
sorry. Yeah.
in front of blah to the negative 2, then I go back in for blah. Okay, so now you're not allowed to leave y prime in there, okay? But go through your rules, because that's a mess right now. So I'm not even going to put, well, yeah, let's do it. All right, so I have a negative times a negative is a positive. So I have cosine y, and this is 1 minus sine y squared in the bottom. So do y'all see I've taken care of all of that?
Yeah.
All right, and what was dy over dx?
1 over
And so I get cosine y over 1 minus sine y cubed. You know what? I'm going to do it with the quotient rule too. Okay? Because I want to show you what happens with the quotient rule. I think we all agree that, and you can run around the school and tell people this, your algebra teachers told you this, the calculus really isn't that hard. It's the algebra after, you can memorize derivatives all day long. It's the algebra after it happens, okay? So, I'm going to do the quotient rule. Even if you got this right, you fully understand what I'm doing it for another reason, just to show you the algebra that happens, okay? All right, so, so I have, what did I have? Y, dy over dx equals 1 over 1 minus sine y. Was that my first derivative?
Yes.
Okay, so say we're going to do the quotient rule. d2y dx2 or whatever it is. All right, so I say low, d high minus high. Be careful with d low. What's the derivative of 1? 0. The derivative of sine is cosine y, but y'all see the negative comes from the statement, not from the derivative. And I'm not through. All of a sudden, I was taking the derivative of sine y, so I say cosine y times what? Y prime or dy over dx. Over low, which is 1 minus sine y squared. I think you've gotten the feeling that you don't want to multiply all that stuff out. Just leave it like it is. I mean, as far as don't FOIL that out. Is everybody okay so far?
Yeah.
All right, now, if they gave me a point, I would fill it in. Right now I have that's gone, minus a negative is positive. So I have cosine y, dy over dx is 1 over 1 minus sine y over 1 minus sine y squared. Okay, so that is cosine y over 1 minus sine y over 1 minus sine y squared. Something I want to clear up so I can move really fast. That's going to give me cosine y over 1 minus sine y cubed. I'm going to do that part pretty fast. Do you see how this denominator just slammed down there with that denominator? All right, if you have 5/4 divided by 3, that's going to end up quickly being 5/12. But let's verify that. Okay? If you divided by that fraction, you would multiply by the reciprocal. When you do that, doesn't that 3 end up on the bottom with that number?
Yeah.
Okay. A lot of that is just so I can, you're not going to need me for the algebra, but if you quit doing the algebra, you'll start to trip up on tests. You need me for the calculus. So I got to kind of verify when I'm flying through a problem what algebra is giving, okay? So if you need to actually write that down as over 1 and see yourself flip it over, that's fine. But you won't see me do that. I'm just going to slam my two denominators together because I'm in my head multiplying by the reciprocal. But if I just all of a sudden do that, I'll lose people. Are y'all okay with that?
Yeah.
I hope I got the same answer both times.
You did.
Yeah, you did.
Good. Okay. Let's do one more today, and then mark what you want to see. We're doing 10, okay? Is that what y'all said?
Yeah.
Okay, and then we can review some more on Tuesday, okay? And your homework is on product and quotient rules, intense AP problems.
Is it with implicit difference or just?
I don't think there's any implicit, but in your mind it is, because after every y, you'll go y prime. Most of these may be y equals.
That's gonna stress me out.
Don't do it, because every time after every y, you go, I'm going y prime, okay?
Okay,
We gotta keep doing some of those. So,
I know.
Yeah. All right.
that's what my brain came from.
If you're finding the second derivative, would you write instead of y prime, y
You'd be like,
prime,
but it don't.
2 prime?
Y double prime? Yeah. Okay, so number 10, cute little puppy, probably need to get rid of. All right. Oh, I didn't want to do that. All right, to fly through number 10.
It's my mistake.
All right, number 10, consider the curve x, y squared minus x cubed y equals 6. Find dy over dx. All right, so here we go. Product rule. So I'm going to say first times derivative of the second plus second times derivative of the first. If I don't do that, I'll lose myself somewhere in this problem. I won't do it to the last one or whatever. All right, the derivative of y squared is 2y, y prime. I'm going to still use their notation today, 2y, y prime. Then I say plus the second. Now what was the derivative of x has always just been 1. All right, then I've got to be careful with this really scary minus sign. Hope you're scared of them. You should be. Beware. This is minus another product rule. First comes derivative of the second plus the second comes derivative of the first. We're going to say equals 0. I can't tell you how many times I'm so caught up in the product from the quotient rule, I just copy the constant down. And it has driven me absolutely crazy because I'll go back through my problem and back through my problem knowing the answer's wrong, but I can't find it. So the derivative of the constant is 0, okay? This is going to be first, what's the derivative of y? Y prime. Sorry, that's messy. And this is going to be 3x squared. All right, so I have 2xy dy dx plus y squared minus x cubed dy dx minus y, 3x squared y, I just kind of fix it up a little bit, 3x squared y dy dx equals 0. I always have to stand back from it and make sure I did it right. Okay,
Where did you pull the dy dx for this last one?
I don't think I have one on that.
Okay.
So I was standing back. When I'm up close to it, I can't really see it very well. These two go together.
Yeah.
And that minus sign just needed to be distributed to 3x squared y. All right, now in the interest of time so that you can go on. I'm going to get these two on the same side. I'm going to add those to the other side. I'm going to factor out dy over dx and divide, okay? So why don't we pick up here, y'all remind me to pick up on number 10 on Tuesday, and certainly if you can't wait that long, please come by, because I love your calculus problem.
I just have a question, like, how do you find maybe a sign? Like, you put for x squared equals 1, you put
Oh, you're taking the rest of the
For all points on the curve, whose x coordinate is 1, so fill in 1 to the original, so you know your x and y, and then you can put it into your slope. Like, once I solve this for dy over dx, or in fact, you don't have to.
Oh, yeah.
I can go up to the original and fill in 1, find out my y value, and just start slapping everything in here. And then you'll know the slope of the tangent line, and you'll know the point that exists. And then where it's vertical, set your bottom of your first derivative equal to 0. So I'm gonna try it before Tuesday, but y'all remind me to pick up on number 10. Bye, girls. Oh, worksheets are right there.
I don't know.
Same.
Here's the worksheets. I'll also post it, because somebody may not have picked one up.
No, I like it's not a